Welcome to a talk on enabling SQL testing in Airflow workflow using Pydantic type. I'm Gurmeet Singh Saran. I'm part of data infra team at Anthropic, and I'm joined by Kushal Thakkar, who is in Cloud Code team. We're really excited about this presentation. Let's get started. So here's our agenda for today. We'll start by exploring the SQL testing, why it matters, the problem statement, and the framework which we've built, basically looking at the solution space, and how we can, make it part of our culture. Introducing any new thing is not easy in any company, be it small or big. So we'll look at some of those aspects on, how we can inculcate into your company. Okay. Let's talk about the elephant in the room, the problem that nobody wants to admit that they have. September 2016, I'm sure you may have followed this news that Facebook was reporting video metric incorrectly for 2 years. They have noticed this after 2 years. They overstated the metric by 80%. And many of the business decisions by advertisers are based on that metric. So they pay Facebook tons of money for advertisement and looking at certain metrics, and they were overstating that. I was in that company during the time when it happened. Okay. Let me paint a picture, and it's not just Facebook. I'm sure every company has some of these stories where small bugs has introduced $1 million loss. So this is like a typical morning for any data engineer when they wake up Monday morning. That's where your execs are looking at dashboard and the numbers are looking off. Maybe those are some wrong joins or some wrong filter condition. Okay. So this is a typical. I'm sure everyone has gone through this in their life, and every company this thing is in some shape or form they've encountered this. Okay, so. Now, some of you might be thinking that, come on, SQL is simple. Like, it's not a real programming language like any high-level language, Python or Java. But I would like to challenge that. So looking at this query, if I assume you guys have some experience on SQL, anybody wants to take a chance, like what will be the output of this query? Like, it's a simple query, 3-4 lines. Okay, let me explain the query, what this query does. It has a bunch of fruits, apple with their prices, and I'm applying some max by function. The max by function is available in almost every engine. What it does is give you the fruit in this case by sorting it by price. So max by, so hopefully the fruit which has the maximum price will show up. Now the output of this SQL queries actually depends. It depends whether that emoji, that fire emoji, is null or not null. And I think if it is not null, then no problem. Every SQL engine would report the exact same fruit because everything is not null. But if it is null, different engine behaves in a different way. For example, and we have tested it, for ClickHouse and DuckDB, it returns apple. And for BigQuery and Snowflake, it returns null. That is because maybe that's the default they use. So imagine if you are upgrading or moving to a different engine, suddenly your same SQL query which worked Friday and it's not working on Saturday because because of this change. So the point I'm trying to make is that even though SQL is simple, but sometimes there's so much of internal details which can lead to a potential bug, and then. Okay, so why don't we test SQL? I've heard all the excuses. Because we don't have time and testing is seen as an overhead, we're always under pressure to shift fast, and that leads to tech debt. And also SQL is simple, which I'm sure I may have convinced you in the previous slide that it's really not that simple, especially in most companies, the SQLs are even 500 lines long, so there's a potential chances of happening that like bugs in your code is much higher than in a simpler setting. Okay, and So this is something I always like to call out. Most semantic SQL changes are manually tested at best, relying on production alerts. And with production alerts, I mean data quality operators or so some kind of data quality check, post-production check, but not like something. And those are always costly. Like the example we have seen in Facebook, like video view metrics were overstated. It was there in production for 2 years, and then somebody reported, and that kind of leads to some introspection internally, like why it happened. Okay, so hopefully I'm able to convince that SQL, even though it's simple, but I think it requires some love, some testing. And as a result of that, I think we started building a SQL testing framework. Let's go a little bit into that. So these are the design principles we followed: zero or minimal footprint. What this means is like when we create test case, especially when we're using some kind of a database engine, it has to create some artifacts, test table, test database, and all those things. We wanted to make sure that we are not leaving any footprint when we run SQL test case, so minimize as much as possible. But there are some cases where it is required, and we can talk about those later in like after this meeting. The next is ease of use and extensibility. So writing and maintaining a test case should be easy, because most of the time people take it as an overhead. Oh, I've done the hard work. I've tested it manually. Now again, I have to write SQL test. So it should be easy enough for people to write SQL tests. So that's the second principle. And the third, which is also very important one, is a dynamic and adaptive testing. So as you know, in a production system, the data gets evolved. When you originally wrote your SQL test, everything, the data you were flowing through was always not null. Suddenly now you get nulls. And those kind of things where as the data gets evolved, you want to make sure that suddenly your SQL test is able to uncover some of those hidden issues. And we'll talk about in detail on how we have done that. But that's also a key factor where suddenly, as your test cases are running in production more and more, they are uncovering those hidden issues, and then you fix it. Here is an example test case, like the structure of the test case. The key part here is that we have a query, but in reality, this query may be very complicated. In this case, it's just a selection of user where user ID is equal to 1. At the top, you have this annotation SQL underscore test, which takes a bunch of mock tables and the result class. And then finally, there's a bunch of assertions like name equal to and user ID equal to. What happened behind the scene is it takes a query and then the mock data and kind of create this transform query, which inject the mock data. And then finally, the data get deserialized into that result class user. And then there are a bunch of simple Pythonic assertion or whatever we want to do with that. Now, the library, the framework which we built, it will let you write this test case, but also let you generate some of these mock data automatically. So as you know, like many of the production table has 200 columns, and nobody wants to pass those ID 1, 2, 3 or different things. It should automatically generate those fake data for you, so that you can only pass the relevant part you're testing. So if I'm testing, okay, for the user ID stuff, maybe you can pass the right email address, but whatever those other columns are present, it should generate those fake data automatically. Now, this diagram shows a complete integration. At the top, the continuous integration. As you know, most companies nowadays, when they define the data the data model, those are generally defined in some kind of Avro data structure, or it could be a DBT model. That's where your schemas are defined, or it could be protobuf, because your your software engineers who are building product, they define all their schemas, not as a MySQL, some create table statement, but some kind of protobuf schema which get code gen into some actual tables. So that's where the real source of truth of your table definition lies. Avro, DBT model, and it could be a create table operator also. Now, for generating the SQL test, a very important part is those Python classes, which can let you generate those mock data, the fake data. So using this source of truth, one has to code gen all these Python classes. Now that is very specific to individual. Like if you have Avro, you have to identify the right code gen which can generate those Python classes for you. Or if it's something else, then you have to write your own code gen. And the final step is the SQL test, which read these Python classes. In our framework, we have built the annotation where you take any Python classes and you put @mockable. It will let you generate those mock data for you for that Python classes. If you use Pydantic HTTP URL, it can do all those validation for you, Pydantic ties, but it cannot generate fake data for you. But that passing that @mockable will generate the right HTTP URL or the right fake email address for you, so that you can use that in your SQL testing. So it reads those Python classes to generate the fake data, run those, and then finally deserialize the data into another model, which you can easily build assertion on. Now, this thing is running in as part of CI build step. The beauty of this step is, imagine a software engineer decided that I want to remove a column from Avro because of deprecation. And most of the time, these are different repo, different system. Only after 2 days, you will realize the data engineer, oh, my pipeline is failing. Oh, somebody in the upstream removed a column. But now imagine, even if the simplistic SQL test, if you have in your pipeline, which is just running the query and doing some simple assertion, can also detect a failure, because now that column will be gone. The Python classes also, the column will be gone. And now your SQL test started failing, that column not found because of this one simple SQL test you had. And now you can go back and talk to the software engineer, like, why did you remove this column or something? So it is running as part of this whole workflow. At the bottom, you have this DAG runtime. Now, this is where it's a typical workflow where you create the table and then we load the data using some kind of SQL table operator. And then we have the data quality operator, which is running on the actual data. Now, using these Python classes, we can also auto-generate some of these dynamic data quality generated. Because when you define something as not null, like in Python, you can define as optional int or something. Now we can leverage that fact and then generate all those column level data quality check for free, because there's no point in, somebody defining in your Python classes that, oh, this is optional or this is an enum. Because most database engine only understands string. They don't understand this is enum, like it only supports certain values. So this is where we're using a better type system, where in your upstream model, you're defining something as enum or something as an integer or a big int or tiny int and HTTP URL, and that get translated as some kind of a data quality check, so that you know in real time whether your production data is also generating data in that. So that's like creating a better data contract. So as a data engineer, when you're releasing some artifact, it's not about, oh, this is a string, integer, boolean or something. This is not only string, but this is of type enum, and I guarantee that with a SQL test and also with this column level data quality check, which is getting generated from that whole upstream model. So where does it fit in? So as you know, there are three kind of quality checks we have, and in the development environment, after deployment, and also like post-production. Now, SQL test, as you may finding issues in the development is always cheaper than something in post-production. And we have, again, I'll reiterate the Facebook example. So that's the reason pushing SQL testing in your development environment, you can catch some of those issues much earlier in the cycle than waiting for some data quality operator or some anomaly detector or AI-based thing to, identify that at much later in the cycle. But by the time the damage is already done, somebody may have already consumed the data. So now I would like to invite Kushal, who can talk about some of those the cultural shift changes you have done, which will help you drive the adoption in your company. Yeah.
Yeah, so I think Gurmeet talked about the technical part and the technical framework behind it. But one big problem is that's probably half the battle, but cultural is the other half. And this is very true for large organizations where you have to actually work through different hoops to actually make sure that the testing culture sticks in. So I'll talk about how to actually go about doing that. You usually hear things when people don't write tests, they're it takes too much time, or sometimes it's boring to write tests, or so I've used some of these things myself, so I don't want to blame others, but it sort of shows up. There's there's this misconception that testing takes time, but if you look at the real, like the hidden cost of not testing, it's actually very high. Basically, we have calculated like up to like 120 engineer hours if there's an incident, and like it also leads to like lost revenue, like customer like trust, and also like team burnouts. And these are not measurable, but they do actually are like very high impact. Now, how do we actually get there though, right? First of all, like start with something simple. Go for tests go for queries which are actually broken. Add tests there as the first phase. This shows like immediate value of your process or tools that you're introducing. The next phase is to like go introduce the CI level checks for testing. So if someone's adding a new query, have a CI level test, check of whether like they are adding new tests. Also ask like in code reviews whether like, to ask to add tests as well. This will increase like good code coverage, test coverage. Also, it will give you that, initial feedback on whether your processes and tools are working. And like sort of use that to like iterate or like improve that over time. The third phase is to just enable tests for every change. This means like changes, any query changes. This actually increases your organic test coverage. But we should be like mindful in this phase to actually not be very prescriptive on exactly very high test coverage, because this can like sort of make it much harder to develop. And the last phase is to actually go like a full sprint. At Facebook, we used to call it lockdowns, but like basically go improve test coverage for like high value queries. If you go look at the incidents that you see, like usually high value queries are the major impactful, are like have caused the most impactful incidents. So increasing test coverage is like very high ROI. It also basically gives you like good progress indicator. Yeah. Also, like doing those phases, celebrate milestones, encourage people to actually do it, like publicize their achievements. How to make it skip? I'll make this culture stick. Generally, it starts with, skepticism. People don't believe in this, so go do demos. Don't go like create documentation. No one likes to read documentation, at least me. So then basically show like help people write their first test. Like that can help like ignite the curiosity of the framework or the processes that you're building. And then also like celebrate success, talk about it in stand-ups or like or like post about it on Slack or something. Overall, like at like over time, like expand scope. Try to actually, if you're doing it only on your team, go do it for your larger org. Yeah, over time, what will happen eventually? This will become the new normal, and then like people will think like how like that would be the normal state of things to add tests. I'll talk about the future, what we are thinking about it in the framework. Um, so what AI powered test generation? So basically, the non-SQL use cases are already doing a lot of AI related AI using AI to generate test cases. I think on the SQL side, we can use a similar approach. We want to support like multiple cloud testing. A lot of companies these days use like GCP, AWS, and Azure. Like a lot of times, two clouds at a time. So I think we want to support that. Gurmeet talked about the DQ checks automatically being generated. We don't have that feature right now, but we want to add that for like make it easier to generate query engine. People use different query engines, and sometimes each of these query engines have like pros and cons and like subtle differences. And we understand like sometimes you want to migrate some of those queries to some other compute engines for various reasons, and making that easy would actually make like would be very valuable, like even commercially, honestly. The other is like this is all about correctness, but at some point you want to do like performance evaluations, performance testing. That's also one area we are thinking about. Yeah. So we have these we think that these are industry-wide problems, not like specific to one company. We have actually been to 3 or 4 companies between two of us, and we have seen similar problems. So we have these tools as open source. The open source framework, SQL testing is the two repos here, and SQL testing is a repo where it provides a framework for unit testing across different compute engines, which is like very popular ones: BigQuery, Snowflake, Athena, Trino, DuckDB. And Mocksmith. Mocksmith is to actually automatically generate mock data. Uh, Both of these combined give you like, bunch of things, and you actually want to expand it. So here's the QR code. Help us like build this as well. Like just check it out if you want. If you find it useful, let us know. Yeah. Thank you.